stay the lecture. If anyone have the question, you can ask me for the display. Yes. Yes.
When we are solving this,
Okay.
we tried a lot, but we cannot find this color. I don't know.
This is line and white and the green. You can go back there. Same with this one. This golden. Yes. But you have to define your own value.
What is this?
This is your minimum and maximum value.
So
50 for maximum.
you said that we need to plot 30 degrees Celsius.
You have to change. Original data is just Kelvin. You have to subtract to change the degree Celsius.
10 is equal here minus
273 blah blah blah, and then you will get the degree Celsius, right?
Here the temperature range is minus 26 to minus 4.
Yes,
Yeah, no, this is currently normal mean. You have to do anomaly also. You got it? Anomaly mean there is an anomaly. The figure is anomaly chart. You see, positive and negative. It's not normal negative. It's mean deviation from mean. How much deviation from mean? Anomaly. This plot is anomaly. I will explain. Okay. So, okay, before studying the coding part, I would like to explain the background, how the GrADS CDO is working on the regression on the graded data. Okay. Okay, suppose that we have two data sets. Okay, we have two data sets with four sets. These are for SST. SST has a grid. Okay, this is our rainfall. Suppose that this is for SST. In each there is a value. Okay, each set has its own value. Okay, and here also value. Okay, how to find these two correlation? Currently, the both data sets are different spatial scale, right? This is a 8 grid set. This is 4 grid set only. How to find the correlation? There's two. And also, this is also there will be another. There will be times that is 12. Suppose that 30 is good. There is a 30-year annual data. Behind this, there is a 30-year, okay, by time. T is equal to 30. In here also, there is a T, again. Behind this, there will be T is equal to 30. Okay. In correlation, there is two way. One is a spatial correlation, and one is a temporal correlation. Regression are also same, okay, just different value only. Okay. In here, I would like to focus on correlation first. To find the correlation for the spatial. Okay, spatial. For the spatial, must be the same graded size. For the temporal, it means it should be same time. All two data sets, and for example, data 1, theta 2. Okay. For temporal, if you want to finding the temporal spatial, temporal correlation or temporal regression, if you are seeing temporal, all data set in your testing, all time step should be saved. It means that if data 1 is 30 time step, this data 2 must be the 30 time step for the temporal. For the spatial, also same. For the spatial, it should be the, for example, you are finding on Africa region. This is an Africa region for, okay, this is Africa region for rainfall, and this is for Africa region for temperature. This is for rainfall. This is a temperature. Okay. But these all are must be time step 1. For example, are the 2090. It should be 1 time step for both data set, and it is a spatial. Both are spatial. It means that you are finding today temperature and today rainfall correlation only like this. Just only you can find only 1 time step, but the spatial variation will be shown how much different in each. For example, this East Campus and West Campus will be different value according to that spatial correlation. Mostly we find it not spatial. Spatial is no need for too much for our research. Mostly we use the temporal correlation. The TER means how AMSO is correlated to your rainfall, or how Northern Pacific oscillation is correlation for your temperature, like this. In here, if I will remove this one, okay. Let's stick to the temporal correlation. Okay, now we have these 2 data sets. To create the correlation rainfall with SST, you have to make the one variable as a y, meaning that you have to find area average first. So which one you want to do? Normally, we make the area average for our own variable. It means the dependent variable. This SST is your predictor. Predictor is you want to find which region SST is influent to your rainfall or temperature. Okay. So that's we have to find that this area average, this rainfall area average. Area average means that in GrADS we already know what is the command for area average. Remember? AVE is a normal average. Area average is a AAVE is a area average. Okay, for coding is no problem. I will repeat again. Now the point is that you have to find one variable area average first in these 30 time step. When you are finding area average for this, you will get the 30 value. 1, 2, 3, 4, take to the 30, right? Okay. In each point, there are also 30 time step, right? So this say only now we only get that like this. Your data is now like this. This is a 1 and T2. This is suppose the 30. Okay. Currently you only have this 1 grid. 4 grid are area average. That's why we got that 1 grid only. 1 value. Suppose that 2 or 4 millimeter or 5 millimeter. Okay. To find the correlation is going to calculation to IMSA. These 2 is IMSA. Okay. For the 4 another time step for the SST, right? This is a T1. This is a T2. Okay. Similar for T2 in here, you have the T2. Also finding for each grid set one by one. It shows that your value, right? It shows that your value. Any question? Clear? Or not? Should I repeat? Yes. Okay. So. You in this figure, you already understand this, right? Our data set structure is like this. The first qubit is a first time step. There is a 1 time step, 2 time step, 3 time step, 4 time step system, right? So like this, I will copy this figure. Okay. There will be 1, 2, 3, 4, 5, 6 time step. Suppose, okay. This is for temperature, okay? This is for temperature. It's a time step is 6. Yeah, 1, 2. There is a time step 6. Suppose that the grade is just 4, okay. For the pressure also. Time step is that T is equal to 6 also, right? Like this. Behind this, okay. Suppose that, but for the pressure, there will be a lot of grid, okay? Because this is a big area, maybe the globe. This is your region currently, your region only. This is because SST is maybe Pacific region or somewhere. It's very bigger than your region, right? So suppose that there is a lot of grid there. But all grids are same resolution. For example, this is a 0.5, this is also 0.5. This is also 0.5, this is 0.5. It means the area is huge, that's why, okay? So, for this, you can find any area average. If you want to detect the temperature, Nino region, you already know Nino region. You can make this one is area average also. It will be changed at this structure. And this is T1, T2, T3, T2, T6, right? Okay. Okay, I will draw all. Okay. T4, T5, and last is at T6. Now, if you find the area average, the structure will be changed like this. If you don't want to find that this one is this, so, for example, this is a Nino. Okay, now you got the Nino. You can detect the correlation is for first time step. This is first time step. So that's grid by grid also. You can calculate. But you must make the one variable for area average fact to find in the correlation. Okay? Now, you don't want to find the area average for SST. You want to find for this temperature. Okay. And then you want to detect with the pressure. You have to find the area average of that. It will be shown like this also. 1, 2, 3, 4. T1, T2, 3, 4, 5, 6. It will be changed this structure. Then you can detect that it's one by one for T1 step. It will be shown in this. There will be show the value and it appear like a map, spatial map, like a normal temperature value or something. Okay. When you are going through that, you will be more understanding. So the command is not too hard. It is very easy. But you have to know the background working. If not, you will be difficult something. Okay. Okay. So for more easy, currently we will use the previous data set, okay? Our SSI.NC first. So please open the NC file. SSI.NC, okay. Okay, our previous data. Okay. We had the 7 variable. So in here, which one is better for us to find? Okay, so air temperature and the 500 omega. Okay, we will find the 850 temperature somewhere to the global omega. Okay, the question, you got it? Question is for, let's suppose the Africa region. Okay, so this is the Africa. Africa air temperature 850 air temperature, and it correlation with the global omega 500 level omega. Omega is, what is the omega? Omega is what? What is the omega? Vertical velocity. Okay, up and down vertical velocity. So omega is a vertical velocity. We will find the the vertical velocity. Okay, we'll find these two correlation. So what should we do first? We have to find Africa area average of air temperature, right? We want to find the Africa 850 air temperature correlation with global vertical velocity, otherwise omega. Okay, so what is the Africa level? Maybe there will be my last question. Okay, so Africa is equal to, first we have to do first what? We have to define the time, right? Currently time step is only first time step. So set T1 less. So it is starting from ending all your data sets. Okay, then we will define the new variable, area average. AAVE. What is the variable name of the temperature? It's air, right? Before this, we want also 850. So actually it's already, but for more confirm, EV 850. Now 850 and Africa is equal to AAVE. The variable name is the air. Then what is the first long of the Africa? Yeah, minus 20 and 60. Latitude is minus 40 and 40. Okay. Okay. So this is a okay. Cool. Maybe I will stand here. Okay. Now we are defining the area average. Africa area average variable name is air temperature A. Long is minimum long is -20. Maximum is 60. West, east, then south and north. Right? So then enter. If your code is right, it will be shown new memory allocations like this 96 bytes. It means already defined new one. If you want to check, it will be shown the Africa, right? It will be shown you time series because we are making the area average, right? So check. In here, you have the time series. It means like this. Now it change this to this. Only 1 point for Africa region. Okay. Follow that? Okay. Follow? Okay. So we already get the time series. We already change like this time now. Now we have to find the correlation. Okay. Correlation. So correlation is we want to find with the omega. Our variable is omega. Okay. For this, we don't need to do anything because all grid size, all time step are same because they are in same data set. So the function is easy. D is equal to no. What is the denote of the correlation? Is what is this? No. The mathematic statistical is R, right? What is the R? Capital is for regression, right? This is for correlation. Okay. Don't confuse these two. Okay. So R is equal to, we are finding the time correlation. The coding is TCOR. This is okay. You see? The command for the behind. The command is a TCOR. It's a time correlation, okay? Maybe I will. Okay? And maybe they are seeing now. Yes. Okay. Now I is equal to TCOR. What two variable? We have to put that new variable name is Africa, right? We have to find Africa and and omega. Okay. Then on what? Now we select the two variables. Then on what? We are finding time correlation. That's why it should be first time step t is equal to 1. T is equal to, we had how many time step we had in the data set? How many time step we have? 12. Okay. So that's 12. These are done. You can find only T3 to T4 is also okay. It's your own, it's not the fault. You can adjust time step as you wish. For example, your data has 40-year or 60-year data, but you only want to find that decadal correlation one by one. For example, decade, you are studying decadal, just one by one. So first, 1 to 10 first, one picture, okay, one figure. Then 11 to 20, second figure. For 40 years, there is a four decadal correlation you will get, right? So this is depend on you. You can adjust anything as you wish. Currently, we are using all time step, first time to last time, okay? Then now is creation on the all time step. Okay, now we will display. Before display, we have to set in time step 1. Because if we display with current 12 time step, you cannot set in the D bar, right? C bar, because it's overlapping 12 figure altogether. Currently, but all are same. All are same, okay? I will show you later. Okay. Now set T1. Then DR. Okay. 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 Now, if showing the correlation, to more clear out, how to do set. Okay. Oh. Okay. Okay. Now these are your correlation value. Please ignore the sun color instead. I already explained yesterday, right? So for more clear out, I use the only 2 color. So now you got the R value now. I will repeat again, okay? I will repeat again. Now I will everything clear out. STS open. My SSI file. Okay, STF open. STS open our file. Before finding the time series, setting time to T is equal to 1 to less. Okay. Then we were setting the level. Level 850 because we have to find 850 at temperature. So then we create the time series. Okay. Time series for Africa is equal to AAVE. The comment is area average AAVE. Then your variable name to area average. Then first longitude is equal to minus 30, comma long is equal to 60. and less is equal to minus 40. Another less is equal to 40. So that we will get the area average. Okay. After getting area average, we have to change the level because we want the 500 geopotential. Set level to 500. Okay. Then we will find the correlation. If you want the clear figure, set display white. Okay. Now R is equal to TCORR. Then your R are free R and omega. Omega on what? On time stat 1 and time stat 12. Okay. Now you got the R value. To display, setting the time step only first, then DR. Now this is your control block for that. Okay. So let's practice. Okay. You got it? Oh, okay. One thing. Okay. R is equal to T core. Okay.
You mentioned here, you said if you want to get varieties of years from say 1985 to the current date of maybe 2023.
Yeah, you can just, if you know, but you have to know your time step. What is a time step file is what?
Okay.
2090 or something.
Okay.
What is your last time step?
Okay.
And also time interval. Some data set are monthly, but you think there is a annual, it will be wrong, right?
Okay, sure.
So you have to show your data set time step. You can adjust anything.
This contour, I don't know why, how to set it. You set it initially, but I don't know its use.
No, it's now okay.
Yeah, it's okay, but
It's okay. What do you want to do?
I wanted to set it the way you put yours because when you run your own, there was no this.
Oh, no, it means set T1 only.
Okay.
Set T1. 1, enter. Then you run again, it not appear. Okay? Okay. Okay?
Is it okay?
Yeah, it's okay.
So y is 0 to 0?
Yeah, it's okay. Now it's working. It's same. Yes. But for display, before display, you have to setting the time step too fast. If not, then you cannot display the color bar or something. Okay, now it's okay. Okay, now it's okay. You can test it if there is a shaded. If you are not setting T1, it cannot display the color bar. Because it means this means all 12 times that figure are plotting together, overlapping each other.
Setting the time to
Yes. Then it means that currently you are calculating 12 times that. If you continue normal display, skip it this one. You just directly display DR. It will be displayed 12 figures together overlapping each other. So you cannot display the color bar. Okay? Or actually all value are same. If you change time 3, it's also same value. You can test it. Time T3, then display it will be show same. Okay. Okay. Color, yes, okay. Oh no, you don't have the color.gs in your library. Did you copy yesterday or not? Oh, maybe you got, brother. How to copy grad? He didn't get the color.gs in the library. Yes, yesterday session he misses. Where is your data download file? My script file. Okay. Copy or paste. English look over it. Yeah, really?
မရဘူးအဲ့ဒါရလုံးကြည့်အောင်ရှင်း
Yeah, you point on it. Oh, yeah.
သမီးလုံးတယ်
นี่ไปอะประมาณ
အဲ့မှာ
ดีเยอะตัวเทศ
အဲ့မနေ့ကတော့နေ
โอเคရပြီလေလောက်တယ်
ဆရာလာမ Thank you. Receive this picture how
print int okay if you got this tab we will continue or follow this step or follow this step because we have to find the significant value, right? 95% significant. Now we got the correlation shape there only, right? You didn't know the 95% significant area. We have to find, right? For more value added. So, okay. Okay, currently we have this spatial map. These are our correlation value. 0.8 and here it is a positively the correlation, right? In Southern Africa. And this is negative, very high negative. Okay, for that, how to find the significant value? Significant value is, what is the theta's equation? Okay, before that I will share the code to you in the group. Did you find the two table figure I sent in the group? Okay. So Does anyone know what is the table? Anyone know? What is this value? Maybe second year master student. They should know. Second year master for meteorology and applied meteorology. They should know. This is for statistical classes. It comes from statistical. Li Li Pin is our Lao Shi didn't teach you, no? This is a T table is significant for the significant student T test. These values are their default value for the percentage significant regarding your correlation or regression. And here, this DF means that your time step. How many time steps in your data set during the correlation? 1, 2, 3, 4, 5, 6, 7, then 30, 60, K to the 1000. Okay? Currently, how many we could have the time step? 12. So it means in here. Okay. We will zoom. No, I can't. Because in 12 time step, there will be 0%, 50%, 60% like this, 99, 95. Okay. Now, normally we find a 95% significant, right? Maybe in behind side they cannot see clearly. Okay. In the below of the last line of the table, you can be see 0%, 50%, 60%. These are the percentage you want to find significant. If you want to find 95% significant, then you go to your time step. Now we have 12. For the 12, in here, we are here. For the 95 is here. So what is the value? 2.17 something. Okay. Suppose that 2. 2 is a T value. 2 is your significant value. It's more than positive 2 is all positive significant. Less than negative 2 is your positive negative significant. Because now we are finding the T test. Now I already shared the equation. What can use in the GrADS? For more clear, I will how to derivation. Okay. Student theta is equal to what? First is the square root, right? Square root is in here, the code. Check the code, please. I already, okay. And 2 is your time step. And minus 2. Then into your R value. Then it divided by the square root of 1 minus R square. R into R is R square, right? So in code, R into R is R square. These are the t-test formula. Based on this, you will get these values, 0 point something something. Okay. Based on this, you can find which value is greater than value and less than value are 95% significant according to this table. Okay. Another figure is same explanation. Okay. But you can check the bear shape. Where are the significant like this? Okay. Maybe you can learn the sun Googling or something for more explanation. Okay. Now we will continue for coding. Now we got the explanation and the code also. So we will copy. Okay. These are the code for the T, right? In here, we have to change the N to what? How many times that we have? We had 12, right? So, okay. Okay. N minus 2 is changed to 12 minus 2, right? Maybe you can directly input 10 or it's okay. Then enter. Okay. I will go down because the RR is not clear. This, then enter. I will display T here. Okay, in here, you can be checked. We already checked which value is significant. More than 2, right? According to our time stat, more than 2 is a significant, and the less than minus 2 is a significant. So suppose that we can just check it here. This region are the 95% significant, right? This region. These are the T value, not correlation value. Not R, this is T. We display the T, student theta result. Okay, now how to combine these two? How to combine these two figures? We had the R shaded. Okay, I will. Now, this is your R value, right? Regression value. And this is a T value, significant value. So, how to overlapping these two together? Okay, we will. Anyone already get this step? Okay. If so, then we will go back to the lecture. Okay, in here, you can use this time script also, and hatch command. Sorry, this is I mistake. There is no H, only HTCH. Okay, okay. Okay. So you can check here. There is a two command you can use. I already get two script, time script and time.gs and hash.gs. You already put in to library. Yesterday I give a lot of script file, .gs file. And then there is a hash, right? hash.gs already, and time.gs maybe time.gs. But the hash is better than the time. Okay, hash can adjust your line. Okay, okay. These are the hash command. Just hash and this is your t value, and your desired significant value, right? Just only this. This angle is your line, horizontal line, and maybe if you are only need 90-degree line, just like this. Maybe you want to like a neck, this will be 2 line, like this, and this will be this for 90. This 100 is only like this, it's like a slide. Okay, when you are displaying, you will be clear. Now we call that this command. So for that, we will display dr first. This is our correlation value. But for more clear, I will change the color style. How to change the color style? Color and minus 0.8, 0.8, and dash kind. Yes, very nice. Kind, and we will do the only red and blue only. Okay, for simple. Dash white dash ID. Okay, now blue and red only. Then we will display the R. Now this is our correlation value. Okay, in here we already had T also. Okay, for T, what is the command for T? Hatch. Hatch T, your own value. Okay. So HATCH hatch, and check here. You can check in the book. Hash then your T, your variable name, right? We have T. T is not default. You can define as you wish. Maybe your name is anything. T is not default. Okay, it is your own name, own defined name. Now we define T test. That's why we put in T. Then what is the value for? Firstly, we will do the negative value first, right? So it means that when we display in DT, what is that there in double? Minus 10 to 40. So minimum is minus 10. According to the definition, it should be minus 10 to below that minus 2, right? Minus 2. Then which kind of the hash you want in here? Angle is which kind of style you want. This is for style, hash style. Okay. Dash. Oh. Angle 55, 1, 3. Now I use less one, okay? Less one for 135, okay. Then just hit. It take your time. It will be slowly here now. It's shaded now, slowly, okay? This means it's working. You have to wait some time. After that, it will be appear GA again. It means it's done. Currently, it's not done yet, right? It's shaded or significant region. This one. Color one. Yes, color. Okay. Two color is here. Color dash. Yeah, this is color. COLO color. This one. This command is to change the color. Because no, it is I minimize, maximize. That's why it's not appear. Sorry. Oh, okay. I will repeat. Let me finish this task. Okay. I will come. Now we have to again for positive value, right? Positive value 2 to what is a positive value or maximum positive value for t? For t, right? So for t. And now it will be shaded again for positive value now, right? Okay. Okay, I'm coming. It's okay. I'm coming.
Command, but we are not having the color. It's not changing.
Dash guy. No,
White to
you are putting dash here. No need dash.
where?
Dash guy, then speed, then blue. No need this arrow.
I don't understand which.
Let me. You are putting. And now it's okay.
Yeah, but it's not giving me the result.
Yes, it's now
Okay, let's clear and see.
clear. Oh, that's why. After clearing, you have to define again.
Okay.
Then the
Yeah,
right.
Yes.
Okay. Okay. Dash guy dash. Okay, this one. No, this one is good.
This one.
No. This one is okay. Oh, maybe you didn't copy my script to your library. Yesterday you okay or not?
Yeah.
Oh.
So we have this.
Oh no, yes. Color dash 8 dash car, yes. Oh, right. I think maybe restart your, maybe you didn't copy my script file to the library. It means the script is not in the library.
Okay.
Okay, maybe you can ask him. Yes.
We are stuck here. This room.
No need to write this. This is automatically here. Brown color. No, negative is fast. Negative value, positive value.
Okay.
Minimum and maximum.
Okay.
Then you are define value.
Why you write here minus kind below and minus What is this?
This is not my.
This one minus.
Oh, dash guy is default common, not minus dash guy. It's default common. Yes. Now you are setting maximum, minimum like this. Then your interval is 0.16. Then this is the grad default. This is you color me. You're calling my script. My script using my script. Actually, a lot of lines are already background and behind.
Okay.
Now it shows that you are default grad default color setting.
Maximum,
Yes.
minimum, and intervals.
Yes.
Just show.
And then these two lines are showing the your default setting for the grad
Okay.
by my script. Okay.
Okay.
Now you can display the here. Okay. Then you can follow the significant part. Correlation. Yes. It's not default. You can give any name you want.
Why you write C? Why you write C?
C is a clear command.
Yeah, the color command is not working.
Okay.
The color command, I saved it as a script, yes script.
Okay.
But if I run this on the color command, it will non-command color.
It means you.
This one,
No correlation.gs.
yeah, it's this one. The one you are doing
Ah,
here is giving me error.
no, in here color.gs. It's not color. color.gs. Color. Okay.
Yeah, this
Oh no,
one.
you are right. This is your name. Okay, I got it. Color. That's okay. Color. Maybe you can firstly copy this line to here.
It's still giving me the same.
Yesterday you okay or not?
Yeah, yesterday it worked.
It means that you open the administrator or not.
Okay, yeah.
Okay. Okay. Okay, thank guys. Is that it? Oh, sorry. Okay.
About this correlation, you are correlating SST, for example,
Yeah.
with rainfall. Rainfall is independent.
Yes.
Sorry, SST is independent. Rainfall is dependent. So now we take time step of rainfall to be maybe GGAS season.
Yeah.
So for the SST, we also need to take time step of that.
No. It needs the sense time step before data manipulating. You have to go CDO first. Then finding. Yes, only you selected only format. Then make it annual. Each annual. Then yes, there is a 30-year time step you will get, but the rainfall is only GGS. And SST also, according to the you are selected. Maybe you are choosing month or something. For SST, you have to choose the prime month of your variable. For example, you want to test in man rainfall. Man, long range rainfall. Man rainfall, you have to choose SST for 4 months. Maybe June, February. January or February.
Same year?
Same year. Or because SST is not influenced directly in time. It delay at least 1 to 2 months. So it means if you are finding the correlation between same time step, GGAS rainfall and GGAS SST is not appear. This GGAS SST are impact to the next after GGAS.
Okay.
You got it? You got my point.
GGAA now you have to take for the SST. You take
GA or yes, for man, GA or something. GGES for month, like this. Right 1 to 2 months of your main season. Your season is GGES. SSD should be month.
Mom.
Yes.
Okay. But
Right 3 months, right?
Yeah.
Otherwise, you can do the summer minus winter temperature also. GGES SSD minus January, February SSD. Then you will get one value. This is your SSD, differential value, and finding correlation with rainfall. Okay.
But which one is better? Which one is better? If I'm working
It's depend on you.
GGE.
It's depend on you. Because sometimes you testing the ignore show significant.
Yeah, because I did it today and I was not having anything.
Yeah. Don't focus on the answer. Somewhere the answer is not influent.
Yes, mine is not answer.
Yeah. Me also.
I'm focusing on Atlantic.
Yes, answer is a global scale, but sometimes somewhere it's not working. Yes.
So now for SST we select some months earlier.
Yeah, IOD is better than the answer for us. Yes. Okay.
Thank you.
Okay. Maybe next week I will go to tutorial regarding this also. Combination of CDO and GrADS.
But the months have to be the same. If you are choosing 3 months for SST,
Yes.
it has to be
Right 1 to 2 months is okay.
for SST also 3 months.
Yeah, no problem. 1 month or 3 months is no problem. But it should be prior.
Right.
Okay. And non-comment, you didn't copy hash GS to your library or not? Color is working, right? So
Okay, so mean I didn't copy.
you did copy it. Well, sorry, where is my file? Maybe hash. This one you have to copy. Yeah.
So copy all the GS.
All GS. These are all my script. Okay.
More of this.
C bar. No. You have to set in 31 first. Okay. And hey, what are you doing here? Hey. Go back. No. Area average. Where is the area average? This is R. Okay, R. Hey. Set T1. Maybe you are setting long let or somewhere. အစနေပြန်ဖွင့်လိုက်စပြန်ဖွင့်ပြီးတော့ရပါ Okay now okay and now I think you all happy
The interval of like
there is no problem. It's no problem. But you have to know the time step is important. Now 12 time step, right? If there's 30, it will be changed. Now 12 is according to the table. We have to find positive or minus 2, right? Greater than or less than minus 2 and 2. So based on the
right, and minus 18 to 2.
No. Now it is a minimum value. It should be minus 80 to minus 2. Okay. Then for positive is 2 to 12. Okay. This one.
If I got it right, so this is the lowest part.
Okay. Then this is a threshold. Your threshold, according to the table. This can be vary, but this is where we fix according to the table. If you are times 30, go and check your in table 30 and what is a 95%. Please open. I will explain you the table. Yes, the figure.
The table, okay.
Yeah, here. Currently we have the 12 times that, right? If you have the 60, suppose that you have the 60 times for clear 30 times that here. So you want to find the 95%, go and check what is the value. It's around 2 saying, right? 2 around, mostly are always 95% are around 2. So we always define the 2 greater than or less than minus 2 and 2. This is the threshold. Based on your t value, it should be 8 minus 80, positive 80 is depend on your data set. This is called threshold.
Okay, that is good. That is what you use for this side, right?
Yeah.
For this.
Yeah.
It's only-
There's a threshold.
Okay, let's talk about the 18.
80 inch come from here. Your minimum value, right?
Okay.
Maximum is 12. So for positive value, it should be 2 to 12,
Okay.
right? Greater than to 2, right?
This 135, I realized that the second one you didn't bring 135, the angle. You only brought the angle.
Currently, you are showing negative value only. This is angle is your line. hash line only.
Yes, but what about
45 and 135 crossing.
Okay, the two of them are all angles.
Yes, all right. Okay, good.
Let me see something here.
H T. You stay didn't calculate T. You stay finding T. Where is your T? This formula. Go to widget. I already gave you the code. Widget. Check your widget in our group. I gave you the code.
0.4798. Yeah.
You have to find. There is no T. You still didn't find the T. This code you have to define and mean that your time step. What is your time step now? 12, right? So n should be 12. Just define. Okay.
Where we get minus 12?
It's when currently you are normally displaying. There is no minus 12. It is 12. Oh, sorry. Yes, sorry. I wrong. I just.
It will be minus 14, right?
Minus 80. According to that, your data set is 80. Okay, for more clear, I want to repeat again for the explanation of this. Hash is calling the my script, okay? Hash.js in your library. This command is calling my script, hash. Then T is your defined value of this formula. It's not default. You can change P, T, anything. Your long name is also okay, significant. This is your defined value of the significant value. This 2 is a threshold value according to the table. Okay, this table. According to this table, is that 2 and negative 2 are come from this table. Currently, we have time step 12, right? For the 95% significant, 12 and 95%, you can be checked here. 2.179, right? For more clear, you can be get the exactly value also. For currently, I only take 2 only, right? So these 2 and this minus 2 are my threshold according to our data range. We only have 12 times that. If you have 30, it will be changed. If for the 30, if you not clear, you go to your widget and check. For the 30, if you want the 95%, it will be 2.042, right? If you want to 99%, it will be 3.64 something, right? This comes from that. This is your threshold value. And what is a 40 and what is a minus 12? These are your T value. When we testing the T issue in here, DT is showing negative 10 and 40. Maybe I round it in this code, but it comes from here. So according to that, your value is minimum is minus 10 and 40. So what should be your code? Hash, hash, yes, your variable name and your minimum value minus 10 and threshold is minus 2, right? This is the first code. Then your angle setting. Then next for positive, this is for negative. For positive also hatch T, then it should be threshold 2. Then what is the maximum value? 40. 40 and then your angle setting, okay? Okay, now I think you all can do your goal research work. These are always the ending part of your research, right? Correlation and regression. Okay, now I would like to show what is a regression comment. It's not different. It is saying with your this one. Okay. Before this says set T1 less. Okay. Now capital R is a regression. TREGR. Sorry, REGR. This is a regression command. For more clear. Then Africa, omega, t is equal to 1, is equal to 12. Okay. Sorry. Okay. Let me check. No problem. It's okay. I will redefine again. So, well, less. Okay. Now R is equal to AF. TREGR. The regression command is TREGR. TREGR. Okay. Let me please. we can see the regression is always come from correlation, right? Regression is okay. Let's go back to the theoretical. Or the hash script are also same for significant, okay? So you can do. And here I would like to literature for these two. What is the difference of these two, correlation and regression? What's the difference between this? Anyone? It's okay. What is? Yeah. Okay.
Question is how much variable relate to the
Yeah. Yeah, your two definition are good for the correlation only, not get the regression. Correlation and regression are relation vice versa. If there is no correlation, there is no regression. There is no regression, there is no correlation. But in here, in the atmospheric science test, you have to find correlation first before any regression. Please note that before any regression work, you have to show correlation, because the correlation tell these two variables are relationship each other. The simple meaning is correlation is these variables are relationship each other by temporal, by spatial, anything. Okay. After showing that these two variables are relationship, you can go the regression. Regression means this variable can be predicted to this variable to finding the prediction. These are finding relationship. These are finding this can be predicted this can be predicted this. Okay, that's why all our study is ending in regression. That's called we call the linear regression. Modeling also like this. Suppose that there is we have the pressure and rainfall and temperature. Then our SST. Okay. We have four variables. According to the correlation test, these four are related each other. Okay. What is the significant value of the correlation? Moderate or strong? It should be the 0.6 and greater than. This is the best. Okay. Okay. Maybe sometimes in here there's four variables. For example, this one shows 0.4. This one is 0.7. This one is 0.8, and this is 0.7 something. When you are making the linear regression model, this one will be give error. It will reduce your regression value. Generally, when you are taking this to regression, it will be show no more than 7. It will be 7.5 or 0.6, between 0.6 and 0.7, according to this value. Okay. That's why since that you are finding correlation, it should be good. It should be better than 0.6. Maybe very small region is okay. Just take it. Don't focus on, for example, Mr. Taminu asked me, He focused on ANSO region only, but there is no significant correlation or for that is variable. There is no problem. We shouldn't only focus on the ANSO and IOD because they are well known. Yes, ANSO is a global influence, but sometimes for some region, ANSO is not too much correlation. It's not so significant. Maybe India Ocean show the significant and Northern Pacific Ocean show these are your predictor. ANSO is a global scale. That's why we always repeat the ANSO. No, not like that. You have to find your own best predictor. Why we use SST? This is according to the physical meaning. SST is very delayed. You can be, for example, today SST can be focused for next month weather. There is a correlation. That's why we use the SST. We can predict more than normal. For example, we know today temperature. We can focus tomorrow, but not sure for the day after tomorrow, right? That's why. But for SST, it's not like that. SST not can predict for tomorrow, but it can be predict for the day after tomorrow like this. Okay, that's why we use the SST for best predictor for our study. Okay, if you got this correlation value, go into the regression, you are finding. In here, you want to find the rainfall. So just a regression of pH and the time and SST. These are your regression model. Our own numerical prediction and NWB model are working like this, not like other. That's why what we are doing, we have to know what we are doing, right? We do a lot of paper, but what is important of this? It means it is important for your model. When you are putting these values you are finding predictor, you can put in the WAF or something if you are modeling. You can generate the good result for your region. Okay, we are doing the basis for the modeling. Our result can be used as a model. Okay, that's why we finding this one. Okay. So according to this, you can create the hash again. This one I don't want to simulate. I will check you one by one. hash, please add on the significant value. Same formula. Same formula. Okay. There is a 0.25, right? Minima is 0.25 and positive is 0.1. Okay. Just replace R small to R capital only in the format. For example, where is your T definition? No. Defining the T. T is equal to blah blah blah. In here,
Yes.
now this is small letter R is correlation. Just change to with R, right? How to find the significant? You have to use this one. Same equation, but you have to check R small to capital R, right? Okay. Okay, continue. I think it's 90. 0.9. Point 2. This 0.9. 2. This 0.2. Yeah là. Okay. Yeah, cái gì nào? Nhá chứ. Nếu mà biểu chẳng nếu bài gì. Nếu bài sẽ không kỳ quay lại. For the regression, you can be check the table first here. Otherwise, here, okay, 0.2. This is for correlation. This is for regression. You already know 0.05 is what? 95%, right? For the regression. These are the percentage. Regression value are always shown in the percentage. Percentage means that it is can be detected or not by percentage. How many percentage can be predicted to that? Sorry? 0.2.
Yeah, because we noticed.
This is for regression.
So regression is
In table, go to table. Upper two row, you can be seen. Yes.
okay.
Check.
So for this one,
0.2.
okay.
Yeah.
0.9.
2T. Yes.
0.9.
Check. If you are testing 1T and 2T, this is 2T. 2T for 2T is this 0.2, 90%. Okay? For 95, 0.1. For significant, there is no default. I would like to explain this again. Sometimes in the significant, when you are testing, it's not always show the 95%. If you are finding 95%, sometimes it will be lost. Firstly, you can find the 99%. 99%. If there is no significant reduction, a little bit 95%. But mostly we take 95%. Sometimes it not appear in your regression model. For my one study, I only take the 70% because there is no 95% for my model, my variable. You can reduce. It's depend on you. It's not fixed. It's not default and it's not fixed. You can be fine. So according to the table, currently I take 0.2, it's 90% significant. Okay. Maybe they need the Coke. Okay. Yeah. 0.2, 90%, T90. 95 you want to, yes, you can adjust. It's not hot. Don't follow my value. you can adjust according to the table, okay? If you want 95%, 99%, no problem, okay? Okay. Okay.
Very good.
Okay.
Yeah.
Now you have to find the significant.
Significant.
Yes.
How to find?
T2 already, right?
Yeah.
Okay. Then the hash comment like previous one.
I didn't get. Sorry.
Okay. That is where you have to check that the significant value. But for the value, you have to know your T value,
Minimum, maximum.
minimum, maximum of the T2, right?
Yeah.
So just
You just write T2.
T2, yes.
Same value.
Yes, it will be show something. Firstly, check T2. Okay, then
Okay. Space
enter.
equal.
Oh, sorry, DT2, please. DT2. No, space.
Space.
No.
Space.
Space
T2.
D2.
Space T2.
Oh, I did spells.
D2.
Yeah.
Okay, enter.
Display.
Now it will be show your value 0.9 and 0.4. Then now you know that.
0.1. Okay.
Okay, now you got it. Then based on this, there is a table I share in the WeChat group, the table. This one.
I'm not including the WeChat group. How can we?
It's you ask to also answer executive. Yes, I mean you or something. Go back in here. This is a 99.
It's a t-test.
Based on the here, according to your value, you can select it as you wish. The range is no problem. 99% is 0.01 or something, right? So according to this here, like this, 0.2, 0.5, like this. So currently I take 90% only.
What is this value? You said
These are the significant value for regression.
regression.
Yeah, this value one is in regression. One is a very significant, right?
Yeah.
But there is no one always.
Yes.
It's 0.9 or something.
Something. Yes.
Based on this, you can be defined 0.5, 0.5 or something. Currently, go back to the graph. And here it show minus 0.9 is very significant, right? But positive are not too much, 0.4. Based on that, you can shade it as you wish. Which part you want to show the significant? Okay. Okay.
Yeah, I don't know. The regression you said we are going to consider 0.2.
Now I think I take this one 90%.
90%.
Yeah.
This is 80.
No. This is one part. This is one part. And here T09, T85. Okay. Okay.
So when you take this value, one you
This is a 9.7. It's 97%.
so how do you is one you put here?
0.9 is very good. Negatively very good.
But I'm having this plot here. The values here is
No, this is T, right?
so this is
R. R is just R. For significant, you have to find T. Same equation, but just R. Okay. Okay, it's okay. Okay. Okay, mostly okay, I found that you are mostly understanding. So let's go back for the exercise. So for this weekend, maybe according to the school activity, we cannot continue in next week. It will be moved to weekday or next week. The inside executive will be announced today. Okay. Before this, you have to do this one. This is a very simply one. Okay. But please, I already gave you the code to provide the arrow shape, right? Arrowhead shape. Don't use the small one. You have to big one. Okay. But this shader is an anomaly. Currently, I didn't show you how to find the anomaly. That's why I will make a tutorial in here. Temperature anomaly, right? Okay. Okay. So, according to the meaning of anomaly, what minus what? Suppose that temperature anomaly. Your air is our variable name, right? Air is minus what? No. We want anomaly. Air anomaly is equal to air minus what? What? Klein is okay. What is the meaning of Klein? Yeah. Mean also air mean. Okay. What is the air mean? Air mean is you have the air1 is one time step, right? First time step. Air2, then so and so T2, air12. Divided by what? There is a 12 times that. Okay. These are the mean of this. Okay. So we will do this one. So okay. The question is temperature. That's why I change the variable. I don't want to show your answer. So let's omega. Okay. Says 500 omega set level 500. Okay. 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 Set level 500. Now we will find the omega anomaly. Firstly, we have to find the mean first, right? Before the subtraction. So omega mean is equal to AVE omega T is equal to 1. How many times that we have? 12, right? So we will find the all times that mean. Okay? This is a mean equation for the omega mean. A. AVE. Maybe omega, yes. Omega is a W mean is equal to why? No. It's AVE. And maybe the level. Okay. No.
Underscore.
Yeah, maybe underscore. Yeah, you got it. Thank you. Omega is that now we got time step for me. Okay. Then we have anomaly. W anomaly is equal to omega minus W mean. Right? One fast and this one second. Now we were testing. We will do the shaded set. Okay. Shaded. Okay. You see, if you are not setting the time step, it will be overlapping or display. You cannot display C bar. C bar is not appear because there is a 12 time step figure overlapping each other. For anomaly, if you want January anomaly is first time step, right? So set T1 is a, oh sorry, T1 is a January 2019 January. Okay, it will be January anomaly will be shown in here. D W A N O. Now this is your omega anomaly for January. Okay. So based on this comment, okay, based on this comment, this is a subtraction. Before subtraction, you have to find the area average. Sorry, the time average mean. You can find the mean of the omega. So let's go back to this one. Okay, I will explain the question. Maybe. Okay, use the exercise MC file. Plot the temperature anomaly, not anomaly shaded in Africa on January anomaly, January 2019 anomaly at level 500 hydropascal. Area 1 more than 30 degrees Celsius should be shaded this. It means you have to change. Currently dataset is supporting Kelvin, right? You have to change Kelvin to degrees Celsius or temperature first. Then plotting the geopotential high contour, this purple line, with the 800 HPA UV wind, this vector. Okay, these are the three variables together in one plot. Contour interval should be 3. For this contour interval should be 3, and the unit must be degrees Celsius. Already changed in here. Okay. Color bar is rounded at. Color bar should be like this. Rounded bar. Rounded bar. Which script you will be used this for this one? For this rounded color bar, which script? Yesterday I gave it. AC bar, yes. AC bar, right? And there is a cell label should be orange color 8 and bold color 5, and for side is 0, 2. Okay. For this, what is a ace plot, right? The command. And matte should be the high resolution. Background should be white. And the grid logo, there is no grid logo. And the grid, there is no grid line. And then you have to say one figure, any title. Okay. So these are the questions. For the font, if you are not stayed up. These 4 arrow setting for wind vector, okay? In here, this one, okay? This one for setting the font level of your grid. First one for color, second one for thickness and the font size, okay? Here. So please finish this question, okay? Then it's a Jua. Okay.